the Rumsey pool.
Okay. You're so excited about math. Here we go. A parametric equation. Okay. F and G are continuous functions of t on an interval. And the set of ordered pairs F comma G gives us a curve. Okay? So basically we have X is a function of t and Y is a function of t. We plug in values for t and it gives us XY coordinates, which give us a curve. Okay. Sometimes we will have an interval. Sometimes we won't. But it's basically going to tell you what values for t they want you to plug in. So you'll have a piece of the curve. Now, here's an example of a parametric equation where up here I have a rectangular equation. Looks like a parabola, correct? And then down here I have a parametric equation. X equals something in terms of t, y equals something in terms of t. What do you notice about this curve that is different from others?
It goes one
Arrows. You have never seen arrows on a curve. Anybody have an idea why there are arrows?
Circle.
Okay, it is a directional graph.
I was going to say polar, so like while you're graphing.
Okay, now this is different than polar. Okay, here we are still on our Cartesian coordinate plane where we have the grid system, right? Where we have those box grids. Okay, polar looks a lot different, right? Okay, we're still on our XY axis, but to get our XY coordinates, we're plugging in values for t. So as t moves along an interval, so this is saying we start at t equals 0, and then we go until t is 3 radical 2 over 2. When we start at t equals 0 and we get bigger with our t values, that is the direction of our curve. Okay? Typically, what are we going to see t stand for, do you think? Time. As time increases, this is where our curve is going. Okay? Now, not always are we going to say it represents time, because we will see some intervals with some negative t values. Okay? It can represent other things, but most often, like we're going to do some good real life word problems on Monday, t is going to represent time. Okay? But first, let's just get the basics down of these parametric equations. Okay? So, to graph them, okay, here I have a set of parametric equations. I define x in terms of t, and I define y in terms of t. And I am saying I want you to graph it when t is between -2 and 3. Okay? All you have to do is make a table of values for x and y. When t, okay, we're going to start at -2. When t equals -2, what's x? 0. What's y? Okay? Then we're going to move to t equals -1. That makes x. And that makes y. Okay? When t is 0, -4, y is 0. All right, do you guys have this equation written down? Because I'm going to run out of room here.
So t is
No, because we have negative t's. Okay. When t is 1, x is, y is half, t is 2, +1, right? And then when t is 3, and 3 halves. Okay? So there are some points for our integer t values, right? Now what we're going to do with those is just plot them. Okay? When t is -2, we're at 0, -1. Then we go to -3, ½ Then we go to -4, 0. Then -3, 1/2. Then 0, 1. And then 5, 3/2. What is it? Grab one. Yes. The whole point of a parametric equation or a parametric graph, it has direction. So you must indicate the direction. Give me a couple arrows. Yeah. Great question. Somebody have an answer for us?
big.
Malik.
As t goes up.
As t gets bigger, we follow our curve. So since we started with t is -2 right here, right? Then we moved to t is -1. Okay, so we followed the direction. Yeah, you can either like plot the points as you go and then connect the dots and draw in your arrows. Okay, but however you find the points, as long as you go in order with your t values, you'll know the direction. Okay? Yes.
Are we gonna learn what we're finding with this?
What do you mean?
Like x and stuff.
We're going to be able to take something like this and figure out the actual equation in terms of x and y. Okay? Which is actually nice. Okay? So, okay, differences between a regular curve and a parametric curve. Okay, first of all, the equations are split up into x and y, so you have things separated out, and you have that direction. Okay. Not always are we going to have to stop. Okay. If I gave this to you without the interval, then we would just draw that. Okay. But most times I will give you an interval. All right. Now, how will we take something like this and squish it into an equation just in terms of x and y?
Solve t.
Beautiful. We're going to have to eliminate t. Okay? So if we can solve for t in one equation, what can we do with that? Substitute it into the other equation. Okay, and then simplify it to where you have one equation with just x and y.
Parameters still exist on your new equation.
parameters were defined in terms of t. So what we're going to have to be careful of is the domain for t. Okay, because we're going to have, let me go back here real quick. T in this equation can be all real numbers. T in this equation could be all real numbers, so that's really not an issue. What would be an issue if we had like a t in a denominator? We'd have to be careful with our domain.
Oh, okay.
Okay?
So it doesn't matter what the initial formula is. Okay. The t has to be greater than -2 or less than 2.
Yeah, we're not going to worry about that. We're just going to talk about like overall shape.
Oh.
Okay? All right. So, here's the first one I want to look at. Hey, look familiar? Okay. We know what we should get in the end, right? We should get what? We get a parabola. Okay. Now, let's look at this equation. What is going to be the easiest t to solve for?
Y equals 2.
Okay? Don't solve for this t. That would be silly. Okay? Let's go to the y equals t over 2. So 2y equals t. Okay? So now we're going to take that and we're going to substitute it into the x equation. So we have x equals t squared minus 4. We have a parabola. Now, you're going to be taking your final very soon. Let's just go ahead and put this into standard form. How do we put a parabola into standard form?
It's almost there.
Okay, you need the x plus 4 over here, correct?
Yes.
Equals 4y squared. So 1/4 times x plus 4 equals what? Okay. What? Now, we talked about this earlier. What's the domain for t in the x equation? All what?
All of this.
We can plug anything for t, right? Yeah. What's our domain for t in the y equation? Okay, so this equation, t can be all real numbers. Well,
why not like x or y or something like that? Because there's no t variable in there.
right. Well, since t can be all real numbers, we will have this entire graph. Now, if t is restricted, okay, let's say t can only be bigger than 2, then we would only have a portion of this graph. We would not have the graph in its entirety. Does that make sense? Okay. Let's look at this one, and maybe this will become more clear. Okay? Well, we're going to eliminate the parameter. Okay. So first of all, I think Chase would really like to talk about the domain. Okay, let's go to the y one first. What do we know about our denominator here? T cannot be -1. Now, what is true about t in the x equation? First of all, if we're under a square root, we have to be positive. So in this case, t would have to be greater than or equal to -1. But we can have a square root of 0, but it can't be in the denominator. So t needs to be bigger than -1. Okay, now I have two different domains. Okay, what we need to look at is where they overlap. Okay, so our domain is t needs to be greater than -1. Okay, now let's eliminate the parameter. What do we do? We do the y?
Probably, yeah. No. Oh, yeah.
The y has two t's in it.
Oh, yeah.
The x only has one.
Yeah.
Okay? Alright. So, I will take your suggestions.
Do the first. Square each side.
Square root side, you just want to get at the square root?
Now.
So x squared times t plus 1 equals 1.
And then.
We want to solve for t, don't we?
Oh,
T plus 1 is 1 over x squared. So t is 1 over x squared minus 1. Okay? Alright. So,
Putting bottom of one to the cancel. Something's divided by a fraction or x squared is equal. Oh, yeah.
okay. So Chase, you say those ones are going to cancel. So I have 1 over x squared minus 1 over 1 over x squared.
Then you just go to the x squared.
Not yet. What should we do first? Complex fractions, what do we need to do before we worry about the division? You need to simplify both the numerator and the denominator. Okay? So that numerator is the same as what?
1 over.
The numerator is the same as what?
This numerator. We need to simplify this numerator. We need it just to be one fraction up there. No. We have a fraction minus 1. What do we need to do with this 1?
X squared over x squared.
We need to have a common denominator. Okay. So now, what's going to happen?
No, isn't the 1 over x squared, doesn't that become just an x squared numerator?
Oh, this is 1 over x squared, isn't it? Thank you. Okay, so what happens there? When we multiply by the reciprocal, the x squared will cancel. Okay? So let's think about what this graph looks like. Okay? Upside down parabola that's been shifted.
Heaven to the right. It's 1 up.
Yeah.
Well, just rearrange it's like y equals negative.
Now this is like what we worked with first semester, right? Y equals x squared, right? Okay. So here y equals negative x squared plus 1. That looks better.
Oh, there you go. Now I'm clear.
Okay. Now, t has to be bigger than -1, right?
So erase some of that.
Well, first of all, what's our value when t is 0? Like, what's our coordinate when t is 0?
1
Fine.
and
It would be 1 divided by 0. No.
it'd be 1 0.
It'd be 1 divided by the square.
It'd be 1
1.
1
1,
1 0
0.
0. I was thinking adding
So this right here is when t equals 0, right? Now we can't plug in -1, right?
So negative 0.9.
Well, so would it be 1 over the book? Like, would it be 1 to the left, 1 0 is
Now let's just make sure our direction is correct. Okay. If t is 1, what point do we get?
Oh, no.
1 over square root of 2.
1 half.
1. Okay. So what's our direction?
To the left.
Is it going? It's going this way, isn't it? Okay. So t equals 1, like somewhere over here, and this is really all of the graph that we have. Instead of the whole parabola, we only have this because of our t restriction.
Oh, sweet.
Carl, does that help?
Yep.
Okay.
Process every time.
I don't think I will have you graph something like this. I think most of your graphs will just give you an interval. Okay? But I wanted to show you why we care about t.
So
Okay.
if it's greater than and not greater than equal to, do we just not have to really find an exact point where it's not like
You're not going to have to do this one. Okay. Let's look at one more.
Wait.
Oh.
You Okay, those ones canceled. Here, I made it to where we had the same denominator. So 1 minus x squared over x squared. And then our denominator is 1 over x squared, so we multiplied by the reciprocal. Oh my gosh, you see thetas.
Ready.
It's still a parametric equation. Okay, instead of t, we have a theta. Why did I put thetas up there?
Because you're easy.
Well, okay, Aaron says I'm evil. Or thetas make sense with trigonometry, doesn't it?
Yes.
Okay, we treat them the same. Okay. However, do you want to solve for theta? And plug it into the other one.
No.
Absolutely not.
We need a different idea. Do we have a relationship with sine and cosine? We have sine over cosine is tangent. Probably not going to help us. Sine squared plus cosine squared equals 1. All right. Cosine theta is the same as x over 3. Sine theta is the same as y over 4. We know cosine squared plus sine squared equals 1, which means cosine squared would be the same as x squared over sine squared is the same as it is an ellipse.
Why did we know this one?
Okay, so ellipse. Center is okay.
And then it's going to be.
Right and left, I'm going to move 3. Up and down, I'm going to move
4. I find the first.
Oh, we're not gonna worry about that. Okay. Oh, well, there.
Got
It's a
it.
really big one.
Bigger.
Okay. Direction. Okay. Let's pick nice points.
Counterclockwise.
Counterclockwise.
3-0.
Let's double check.
All right.
When theta is 0,
Yep.
we get.
3 and 0.
Okay, so we're starting there. Let's go to an easy one. Pi over
Pi
2.
over 2.
X is.
0.
Y is.
4.
Okay, so we're going this way.
But where do you stop?
That is a great question.
Nobody knows.
Okay? This is just gonna keep going and going and going and going and going and going and going, okay? So we can just say that theta is gonna be between 0 and 2 pi. That way we don't keep going and going and going and going.
But that's not.
If you put your calculator into parametric mode, then you can tell it what t values you want it to plug in. Then it'll go to whatever its default is. You can't say infinity. Okay.
Are we gonna
Yes.
use like such?
Okay. All I did to find the direction is I started with 0 radians, and so when I plug 0 in here, we get 3. When I plug 0 in here, we get 0. So 3, 0. Okay. And then at pi over 2, this goes to 0. At pi over 2, this goes to 4. Positive 4, right?
So what would it look like if the direction was the other way? What would the next point?
If the direction was the other way, then then pi over 2 would go to a point down here.
Oh,
And so then we follow it that way.
If it was negative 4.
So it'd be, yeah, it was
Yeah.
negative 4.
Yep. There you go.
Are we gonna learn how to do it on the graphic calculator?